Great. Hey, everybody. Welcome to my talk. We are going to talk about when JavaScript takes its coffee breaks. I know the title is a little bit, but we are going to see literally when JavaScript is going to take its coffee breaks. So before getting into the talk, I want to ask a question. Who has already seen Ted Lasso? OK. We have some guys who have already seen that, but I'm literally very jealous to the ones who haven't seen that. Guys, you're going to have a great series ahead. So please, give it a watch. So let's start. Have it happened to you go see a JavaScript code and say, what? It doesn't work correctly? Or you literally don't understand why it does or why it doesn't work? Thanks. Ignore. OK, so for instance, in React, we have some asynchronous operations. Sometimes you should know the differences between use effect, use layout effect. Or sometimes Angular. Angular has some change detection mechanism behind the scene using Zone.js. So all of these things are dependent on one topic, which is event loop. We are going to dig deeper in a couple of minutes. And also sometimes in JavaScript, maybe some interviews, they ask you some crazy questions like this. So which console logs comes first? Which console logs come last? So these are the questions that we are going to answer by the end of this talk. But you know, before understanding event loop, me, as a developer, I was blaming JavaScript. Oh, it's JavaScript fault. It's crazy language. But no, it's just about basics. If you read basics, if you understand basics, it means that you know everything. So we are going to take a look at basics. My name is Mohamad. Everybody calls me Mo. I have 15 years of experience as a tech lead developer. It doesn't matter. I'm just a developer for the community here to learn from you, and you can learn from me. I work across 4 different countries. As a personal note, I have 2 kids. And also, I love playing video games with my buddy, my son. So let's start. We start with the basics. Then we are going to take a look at the task. How does JavaScript handle tasks? And then event loop itself. Then learn by practice. This is the time that I need your hands, right? I saw that it works for most of you. So I need some hands, A and B. So you're going to answer, and based on your answers, you're going to learn. A quick demo of event loop in the browser, and some bonus tips. JavaScript basics. The most basic thing that my talk is about is JS is single-threaded. So there's one thread in JavaScript that handles everything. So if that thread is blocked, the whole browser is blocked. So we're going to learn some depth later. So handling tasks. So since JavaScript is one single-threaded language, so it should handle tasks behind the scene. So what are those tasks? One of them might be a while. A while true. How long does it take? Forever, right? Until your browser tab tells you that it's blocked, so wait or exit the tab, right? So the thing is, everything in JavaScript happens in a synchronous way. Synchronous way, it means one after each other, one after each other. Very important, keep in mind. And sometimes we are dealing with long tasks. It's not a normal task that happens sequentially in a synchronous way, but it is something that we should wait. For instance, we have a set timeout. We should wait for an interval. We have a fetch. We should wait for the third-party server to respond back to us, right? So these are the things that I call them long waiting tasks, even geolocation. So you are dependent on your hardware to get the geolocation from GPS and stuff. And these things we call asynchronous. So synchronous versus asynchronous. But the whole topic that we are going to cover is on the asynchronous part. So now it's time for event loop to come into play. We know that something is asynchronous. So something happens somewhere, and we should expect a response from that. This is the time that event loop comes handy. There's a code snippet that I'm going to use. I'm going to go through each line in terms of the event loop with each other. Keep in mind 2 simple functions. First one, foo. Second one, bar. Foo is returning something. What does bar do? just initiate a set timeout. So we are dependent on an interval. In this case, 1 second. So let's start. You know that all languages are dependent, in order to run codes, are dependent on one thing, which is call stack. So we have a call stack. Just imagine that I want to start running the code on line 11, foo function. So as soon as I put foo in the call stack, so it is in the call stack, right? So call stack is last in, first out. So is there anything inside the foo to run? No, it's just a return. It just return and get out. So nothing specific. But when it comes to bar, as soon as bar go to a stack, we initiate a set timeout on line 6. So this is the time that event loop should come in play and everything happening in an asynchronous way, right? So in this case, there is a set timeout. We want to run set timeout. So as soon as we reach set timeout, which is in our call stack, a magic happens, which is Web API. Web API is a place in the browser. Just imagine that it's full of services. For our task, it's timer service. So the timer service is responsible for waiting for your interval. In this case, 1,000 milliseconds. So we register a callback there in the Web API. Web API wait for 1,000 milliseconds, and then it push the call stack and put it in a queue. So call stack is empty, Web API is empty, but we push something into a queue. This is important because at the end of the day, our code's supposed to go to queue. If it's supposed to go to the call stack. If it goes to the call stack, it means that we are running that. So somebody pick this task, pick this callback, which is event loop, and put it in call stack. So yeah, the rest would be the same, right? So if we put it in the call stack would run it like a normal JavaScript. So keep in mind the flow. Call stack, Web API, queue, then call stack. So everything would be in a loop. And this is one of the most important things that most of the developers confuse. So where does browser render happen? Browser render happen in this case when call stack is empty. When call stack is empty, browser render happen. There are some questions that coming that are dependent on this tip. Keep in mind. So let me recap. We have call stack, some functions are there, set timeout, fetch. Set timeout goes to timer service, fetch goes to network service in Web API. As soon as that API resolve, in timer, waiting. In fetch, getting a response from the server. As soon as we get that, we're going to push them into the queues. Queues are there to help us, again, put them in the call stack to run our callback. So let me show you this simple code snippet based on the things that we just learned, right? Imagine I want to insert an element, append an element to body. So first, what do? I append the element, then hide it. I don't want anybody to see that, right? So what if 1 millisecond my user see the element? I don't want to see them, right? Because I want it to be hidden. So wait a moment. What about swapping these lines? So first display none, then append it. Does it fix my issue? Even was that an issue from the beginning? Yes, but no. No, it's not. Why? Keep in mind, when browser render happen, call stack is empty. So it means that during running my code, even render doesn't happen. So code A and B are the same. Even for this one, I want to flash my element, just a normal flash. Does it flash my element? No, because it's running my code. So when it runs my code, main thread is blocked, no render happens. Browser render happen at the end, so my element would be visible in this case without any flash. This is the time that I need raising hands. So there are A and B. You can go for it. A, right, left, B, right? Let's see. A console log. Which one is correct? Yeah, I can see hands moving. Nice. OK, so in this case, so simple. A simple log. But what if I add a set timeout? Set timeout with second parameter is 0. By default, it's 0. As you see, it's not 1,000 anymore. So which one? Here timeout or timeout here? A? B? The answer is A. Although the interval time, the duration was 0, but in practice, it takes around 4 milliseconds. But anyway, just imagine that this callback, which is the callback that I passed to the set timeout, should go to the web API, then go to the queue, then to the call stack. So at the end of the day, first thing, because everything happens sequentially in a synchronous way, console log first one is here is the first. And then set timeout, then it goes to the web API queue, and then running. So there is a dotted line that I put in the A column, as you see. The thing is, it shows you the render. It shows you when browser just rendered in between my tasks. Why it's happening, we're going to see later. So what if I swap them? First, set timeout, then console log. Does it change anything? No, it doesn't. Again, A is correct. Why? Because, again, that process is supposed to happen, but console log here would be the first. So render, again, happened between here and timeout. Why? We're going to see. So I just added line 7 to 9 with a promise. So a promise has been added. So promise comes after timeout or before timeout. It comes before timeout. The reason? There is a reason behind it. Both of them are tasks, but different tasks, different queue. So what is the reason? The reason for that is we have two queues in JavaScript in event loop. One of them is microtask. The other one is task. So microtask priority is higher. So that's why if we push two items to the queues, which one will be picked first based on the priority? Which one has higher priority? Promises, microtasks. All promises are microtasks. So what if instead of using promise.resolve, I generate a promise for myself? So it is the body of my promise. I'm resolving my promise manually. A? B? The answer is A. Why? Because of this reason. You know, the callback promise, the body of my promise, the body callback of my promise runs instantly as soon as I generate my promise. So it is literally like that. Just imagine that you have a function, it accepts a callback, and you run callback immediately. So the answer would be here, body, promise, timeout. So, and the render, where does render happen? Yeah, there is a render after body. So it's just another example with set timeout, two set timeout, but one promise inside one of them. Let's see. A, B. Yeah, the answer is A. What is the reason? The reason lies behind the pick logic from queues. I'm going to show you a slide. In that one, I'm going to clarify this one. Why promise comes before timer 2, although both timers were initiated at the same time, right? So, you know, we just see that how does task and microtask works. There are some tasks like set timeouts, some microtasks like promises. But can we use those to block the main thread? We have one thread, right? Single thread. JavaScript is single thread. So let's block that one. Just imagine I want to block my main thread using promises. So both of them would be the same, right? The answer is here, 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 here. But the difference in these two are the renders. In B column, we have renders after each here. But in the other one, we don't have. Do you have any clue? We're going to learn it. No worries. A? B? Actually, the answer is A. Why? We will B, sorry. No, A, sorry. My mistake. I just forgot to swap the check marks. But we are going to learn in the chart that I'm going to show you in 1 second. So if I do that with set timeout, does it change anything? So in the previous one, there were no renders. But in this one, there will be renders. So in each one, we are going to have a render. So it is an infinite loop, right? Because I'm calling my function all the time. And also, we have request animation frame. I'm going to show you how does that work here. So we are dealing with task and microtasks, right? So the first one is task, like set timeout. There is a queue. I pick one, I start running that, and just imagine in that one, I add an additional one, right? So how does my browser event loop interact with that one? It's going to run it, an additional one, just skip it. It's not going to run it anymore. But in animation callbacks, it's a little bit different. If you use request animation callback, it picks one. If you add an additional one inside your callback, it's going to ignore it for the moment because we haven't reached that. Yeah, it's a queue. Queue is first in, first out. So it's going to start from the bottom to top. So it picks one, another one. Again, it adds another. It picks another one, adds another. So it goes and goes and goes. But it stops as soon as it reaches additional items. It doesn't continue rendering additional items, running additional items. But in microtask queue, it's a little bit different. Again, it picks. If you add a new one, it's going to run it. It's going to put it in the stack, run it, and also continue running additional items. That's the difference. So with the knowledge that we just learned, it means that for the tasks, it's going to pick one by one. For the animation callback, request animation frame, it's going to run till additional items. But for the microtask, it tries to empty out the queue. So the whole recap would be something like this. So for the microtasks, it's going to try to empty out. For the task, one by one. For the request animation frame, empty out, but not the newly added ones, right? As you see, I put some dotted lines there. Because request animation frame queue somehow doesn't have any priority. Priority of microtasks are higher. As you see, it's on top. So if something is in my microtask, it's going to pick it once and run it before tasks. But the request animation frame happens whenever browser requests for a render, right? Can somebody guess what does request animation frame rate dependent on? Yeah, it dependent on your screen refresh rate. So the guys who do animations in browsers, deal with that one as well. So for instance, in this case, I just checked out. This screen is 60 Hertz. So it just runs request animation frame 60 Hertz. And if you are a tech savvy, there is a website, the UFO thingy that you can check the ghosting of your screen and the stuff, and it works with request animation frame. So that's the pick logic. But we just learned that JavaScript is a single-threaded, right? But does it mean that we can't have anything parallel? Of course we can. But it lies in web workers, in browsers, and in Node.js, we have worker threads. We had Matthew around. Matthew mentioned it this morning in his talk in the main stage as well. OK, nice. So a quick demo. What do I have? I have 3 elements. The first one is move task. I'm moving this one with task, set timeout. The second one, I'm moving this element with microtask. And the last one, I'm moving that with request animation frame. Let's start with the first one. I want you to focus on my animation in the middle. It's a normal CSS animation, right? So if my browser, the main thread, is blocked, so it means that my animation won't move. Let's try. First one, yeah, it moves. Yeah, let me refresh. Try request animation frame. Yeah, that one moves as well. And it moves 60 frames per second at the moment. Not 60 frames per second is better to say. 60 times per second it adds to the moving. OK, so what if I click on microtask? So as soon as I click this one, yeah, my browser, my main thread would be blocked. So what was the differences between these that caused this effect? Yeah, because microtask tries to empty out the queue. Because I'm trying to move the elements running the same function all the time, once after each other, it blocks my main thread. Yeah, this is the famous alert that you get when your page is not responsive, right? Yeah, that's easy. So let me check something else for you as well. If I click on move it task, and also request animation frame somehow at the same time. Oh, I clicked twice. Task is much, it goes faster. And the reason behind that relies under, again, 60 frames per second, 60 hertz monitor. Because my monitor is 60 hertz, and set timeout, as I mentioned, set timeout takes, with 0 millisecond, it takes around 4 milliseconds to run, in practice. So just imagine that 60 frames, 60 hertz, right? I have 1,000 milliseconds. If I divide it by 6, it would be 166. So it runs my set timeout 166 times, but my request animation frame 60 times. So that's why they are different. So the speed is totally different. So if I run this one and run this one goes faster because 166 times. And if I click on microtask, everything would be freeze because my main thread would be blocked. OK. Let's move on. Some bonus tips. First one is there is a function in browsers, instead of using promise.resolve and then putting your callback. Yeah, it's not best practice. Best practice is using queue microtask function, which is available in all browsers, queue microtask. So since both of these are microtask, right? One of them is promise, the other one is queue microtask. Both of them considered microtask. So based on the priority, queue microtask higher priority than promise, because it comes first. And also in Node.js, we have a concept of nanotasks. Nanotasks, you can trigger them using process.nextTick. This is only in Node.js, and it has highest priority. So nextTick, then queue microtask, because the priority is higher. So there is another queue there as well. There is a new API coming in browser. Right now, it is stable in Chrome and Edge. No Safari. Firefox is under a feature flag. You can check out caniuse.com as well. So this scheduler is somehow a replacement for doing some hacky, like set timeout and stuff. And also, as you see, it has a priority property, which contains user blocking, user visible, and background. So I guess now you get the concept behind this. So next time in your project, if you are dealing with a use effect, use layout effect, or maybe some change detection in AngularJS, for instance, AngularJS, Zone.js has a feature to run something with priority using its internal functions. All of them are dependent on event loop. So if you know the concepts, it's going to help you understand your framework better. You know why I always insist on basics? Because frameworks are coming and going, right? It was just a couple of years ago that each day we were saying to ourselves that yet another framework, right? There were a lot of frameworks. And each framework adding new features, publishing, breaking changes, new API. You should learn all of them, by time. But basics, they never change. All the concepts that we learned today are same in all browsers. That's why I didn't cover any compatibility chart that this feature is here and this feature is there. And also, maybe in one of your interviews, somebody asks you a question about event loop. You know how to fix it. Resources, first talk from Jake Archibald. I highly recommend that. He did a great job in describing event loop with good animations. A scheduling task from Google Developers YouTube channel. That one is perfect, guys. Just HTTP 203 podcast from Jake Archibald and the other guy on YouTube, perfect. So in-depth talks. How not to use use effect. It's a talk from me at React London, I guess. So I talked about use effect in React in terms of the event loop. And also, yeah, if you want to learn more about event loop in Node.js, there is a link. And yeah, and this one is very important, processing model. As you see, the link is coming from, who knows this website? It's a website that stores JavaScript specification. So processing model is the event loop that we just learned. So all the things that we learned is part of the JavaScript specification. It means that they never change, so they just keep updating and adding features. And all browsers develop that. And the last one is, yeah, the one that we just learned, new API that is coming to the browsers. Yeah, thank you. Looking forward to see you at ING booth. I have some small gifts for you. And if somebody wants to dig deeper into the performance tab of the developer tools in terms of the event loop and how you can debug that, see me at the ING booth. Thank you.